Hello everyone. The topic of this video is chemical equations, and the purpose of this topic is to practice representing and balancing chemical equations. So when we write chemical equations on a piece of paper, we are going to start out with our starting material, which we call our reactants, and proceed to what we are trying to form in this chemical reaction, or our products. And we separate the reactants from the products typically with an arrow, and that arrow is going to point towards your products, at least starting out. On the left-hand side, we have our reactants. On the right-hand side, we have our products. Now, if we have more than one reactant, we're going to represent that with a plus sign. And same way on the product side, when we have multiple products, we will separate those with a plus sign. Now, each reactant or product, there is going to be a phase or a physical state. And the ones that we focus on in this class are a solid, liquid, and gas, which you're probably familiar with. And the last one is aqueous. Now, when we see aqueous, that just means dissolved in water. So, for example, if I had the chemical formula of sugar and wrote aqueous next to it, that would mean sugar dissolved in water, or sugar water. Okay, so the abbreviations for solid will be an S, for liquid is a parentheses L, G is parentheses, or gas is parentheses G, and aqueous is parentheses AQ. And you do want to include parentheses around those phases to distinguish them from your chemicals. All right, now if you notice, when you look at the picture example of this, CH4, our first reactant here, it is an entire entity composed of 1 carbon and 4 hydrogens, and you can see that picture below. And oxygen, same way. O2 is 2 oxygen atoms that are bound together, and that coefficient in front tells us how many oxygen molecules that we have. So the subscript O2 tells us that in a single molecule we have 2 atoms of oxygen, but the coefficient 2 tells us that we have 2 molecules of O2. And you can see the example over here with H2O as well. So hydrogen is represented by the white, okay, so that's your hydrogen, and the red is your oxygen. So in a single molecule of H2O, we have 2 hydrogens for every 1 oxygen, and that is 1 H2O molecule, and below it we have a second. So again, that coefficient 2 in front represents how many water molecules that we have. And the reason that I'm pointing this out is because whenever we start balancing chemical equations, we can change the coefficient. Okay, so you can change the coefficient. What you cannot change are those subscripts. So CH4, for example, that has to remain CH4. If I wanted to add any carbons to the reactant side, I would have to put a coefficient of 2, 3, or something in front, but I could not change that CH4. Okay, so when we are balancing chemical equations, our goal is to have the same number of atoms on both sides of the reaction. And so when we look at a simple example here, on the left we have an unbalanced reaction of H2, hydrogen gas, plus O2, oxygen gas, yielding H2O, or water. So in the unbalanced reaction, if you notice, we have 2 hydrogen atoms combined in an H2 molecule, 2 oxygen atoms combined in an O2 molecule, and then in water we only have 1 oxygen and 2 hydrogens. So looking and counting the number of hydrogens on the reactant side, we have 2 hydrogens on the reactant side and 2 hydrogens on the product side. So the hydrogens are good. So I'm going to make a little list up here in the top. Hydrogen and oxygen, the 2 atoms or the 2 elements that we're looking at. and hydrogen is originally okay. The problem is that we have 2 oxygen atoms on the left-hand side and only 1 on the product side. So if we want to increase the number of oxygen atoms on the product side to match how much that we have on the reactant side, we cannot change the H2O molecule as it is. The only thing we can do is add more H2O molecules. So I can add a second H2O molecule. And when I do that, I have to place a 2 as the coefficient in front. So what that means is that I have 2 H2O molecules. And you can see that they've already done that here on the right-hand side, on the balance side. So they added a 2 to increase the number of water. Now, once I do that, the oxygens are now happy because I have 2 oxygens on the reactant side, and I have 2 oxygens on the product side. The problem is now that by increasing the number of oxygens, I've added more hydrogens. So you can see I have 1, 2, 3, 4 hydrogens, and I only have 2 on the reactant side. So if I want to add more hydrogens to the reactant side, again, I cannot simply just add a hydrogen as a single atom, or I can't add to the molecule of H2 that's already there. I have to add another H2 molecule. Okay, and again, the way I represent that in the balanced chemical reaction is by adding a 2. You can see this red 2 on the right-hand side, and that shows that I have 2 H2 molecules. Okay, so I know this seems overwhelming at first, but we're going to keep going through more practice examples. But the idea, something to keep in mind before we get started, is that you can change the coefficient. You can change the big number in front of the compounds, but you cannot change the compounds themselves. So in this set of exercises, all we are asking is if the chemical equation is balanced. So I will try 1 and 3 with you, and then you can do 2 on your own. So for number 1, I think that something that helps when you're balancing chemical equations or checking if they're balanced is to first ignore those phases. Okay, they're very important, but for balancing equations, they're not very useful. So we can focus in on the atoms themselves. And so for number 3, I'm going to go ahead and do that as well. Now, the next thing that I think helps is to write out a checkbook almost, where you include on the reactant and product side how many that you have of each atom. So I'm going to rewrite number 1 up here in the top. We have 2 sodium atoms plus 1 oxygen gas yields 2 sodium oxides. And I'm going to form a line directly under that arrow. And on the left-hand side, I'm just going to write the type of elements that I have, which is sodium and oxygen. And I'm going to do the same thing on the product side. We have sodium and oxygen. Okay, and then I'm going to just make a list of how many sodium atoms do I have entirely. And the way you figure that out is that you do have to multiply the coefficient times the subscript. So for sodium, there's no subscript next to it. We assume that to be a 1, which means that I have 2 sodium atoms. And then for the oxygen, there's no coefficient in front of it, so again, that's assumed to be a 1, and so we simply have the 2 oxygen atoms coming from that subscript. So the 2 sodium from the coefficient and the 2 oxygens from the subscript. Now, on the product side, if you notice, I've got a 2 as a coefficient, and I have a 2 as a subscript next to that sodium. So for sodium, I'm going to have to multiply the 2 from the coefficient times the 2 from the subscript. So I have a total of 4 sodiums on the product side. And then for the oxygen, there is no subscript shown. So again, when there's no subscript, that's assumed to be a 1, and 2 times 1 is 2 oxygen atoms. But we can already tell from the sodium that there's 2 sodiums on the reactant side and there's 4 on the product side. So number 1 would be no. That equation is not balanced. Okay, so let's try this again for number 3. Now number 3, again, I'm going to put an arrow or a line directly underneath that arrow to separate my reactants from my products. And then I list out each element that I have, which is silver, nitrogen, oxygen, potassium, and chlorine. Okay? And however I list them on the reactant side, I want to go ahead and match that on the product side. So we're going to have, again, silver, nitrogen, oxygen, potassium, and chlorine. Okay? Now on the reactant side, there's no coefficient in front of that compound, so it's assumed to be a 1, and there's no subscript next to that silver. So we have 1 silver atom on the reactant side. Nitrogen, same way, coefficient, there's still nothing in front of it, and there's no subscript next to the nitrogen, so that's a 1. And then oxygen, no coefficient, but the oxygen has a subscript of 3, so we have 3 oxygens. And then for the potassium chloride, keep in mind that that coefficient is going to distribute to every element in the compound. So that 2 not only applies to the potassium, but it also applies to the chloride. Because remember, if I were to draw this out, I'll draw it out up top here. We have a potassium and a chlorine, and that's 1, and then we have a second one because there's 2 of them, so a potassium and a chlorine. So we have 2 potassiums and we have 2 chlorine. Okay, now on the product side, silver chloride, that's a simple 1 and 1. There's no coefficients or subscripts to be seen. And keep in mind that I have to find the chloride, which is at the bottom. Okay, so silver and chloride, 1 and 1. And then potassium, no coefficient in front here, so that's 1 potassium, 1 nitrogen, and 3 oxygens because of that subscript. So again, on the reactant side, the silver is the same as the product side, the nitrogen is the same, and the oxygen. But the problem comes in with potassium and chlorine because we have 2 on the reactant side and only 1 on the product side. So again, for number 3, I'm going to say, no, that's not balanced. Okay, so we're going to stop this video and pick up with how to balance chemical equations in the next video.